Hi, so in this video we're going to talk about forced vibrations, also known as resonance. We're going to look at what is natural frequency and what do we mean by the term resonance. So every object in the universe has the ability to vibrate like a mass on a spring. An example would be the floor of a building. No doubt you have probably been in a large building such as a mall, and you may have felt the floor vibrating as you're walking through the mall. So that's an example of resonance. A building itself can sway back and forth. It can be forced to vibrate. Things like that happen due to wind pushing on the building or during an earthquake. The ground can also vibrate up and down. And again, a good example is an earthquake or perhaps a train or a car or a truck driving by nearby, and you feel that the ground is vibrating up and down. That's an example of a mass spring system. A bridge, as you cross a bridge during traffic, maybe perhaps during rush hour, you're stuck on the bridge. You may notice the bridge is actually, or your car is moving up and down. The reason the car is moving up and down is because the bridge is moving up and down. The bridge has mass, and it's behaving like a simple harmonic oscillator. Water moves in waves. We see that. Water has mass, and it can behave as a simple harmonic motion system. And my last example is a wine goblet. No doubt you've heard a wine goblet vibrate when someone just strikes it. I just so happen to have a wine goblet, and if we tap it, it vibrates. I force that vibration by tapping it, by applying a force to the side of the wine goblet. So each object vibrates at its own specific natural frequency, called its natural frequency, or also known as resonant frequency. So our wine goblet, that characteristic sound that helps us know that that is actually a wine goblet that we hear, we can differentiate between sounds based on their natural frequency. If someone drops keys, that makes a distinct sound. Keys have a particular frequency range. So an object can be forced to vibrate by applying a force to it, just like applying a force to a mass of a spring mass system, causing it to go into simple harmonic motion. Forcing an object to vibrate causes it to resonate. And resonate means vibrate at its natural frequency. So let's look at a simple example, one that we're probably all familiar with, pushing a child on a swing. So I have a sketch here. A swing is just like a simple pendulum. We have a mass suspended by a length L, and what we do is we raise the child up, and then we release that child, and they swing back and forth, back and forth. That's simple harmonic motion. So resonance occurs only if the frequency of the push is exactly paired with the oscillation of the swing. Now, the frequency of a swing, or frequency of a pendulum, is summarized by this formula. We see that the frequency of a pendulum is dependent only upon its length and the acceleration due to gravity. It doesn't matter how heavy the child is on the spring. So as the child is moving back and forth, we know that we push right at the right moment. So if the child is near me, that's when I apply a push, while the child begins to move away from me. If the child is over there, well, I'm not going to push because I'm actually not going to be in contact. I'm also not going to push when the child is approaching me because that will stop the swing. So I can force that vibration, and I can actually increase the amplitude of that vibration if I am in sync with the frequency of the swinging child. So let's have a look at breaking glass. So back to my wine goblet. So a glass goblet can be shattered by forcing it to vibrate using a frequency of sound identical to the object's natural frequency. So this is the natural frequency of this goblet. So if I produce a similar sound, that sound will push against the glass, causing it to vibrate at the same frequency. So I can get this to make that sound by producing an exterior sound. So what will happen is the exterior sound will push against the glass, and the glass will act like a simple harmonic oscillator, and it will move in one direction as far as the glass can stretch, and then it will snap back, pass through the equilibrium point, and come to the forward direction. And it'll move back and forth like that as it vibrates. When I tap it, I do that mechanically. I push on the glass and I push it inwards, I bend the glass, and the glass snaps back just like the spring in a mass spring system. So if the amplitude of the sound is large enough, that is loud enough, the amplitude of the goblet's vibration may exceed the flexibility of the goblet. Now when I say flexibility, we're talking about the spring constant because this is able to flex, so it's behaving like a spring. So if we exceed the flexibility, the glass will shatter.